I want to show you a bit about ESQL, which is very new, hopefully also very exciting, but we'll see as we go along. So it's the Elasticsearch query language. It's ES-pipe-QL. Why did we make such a weird name with a pipe? Because otherwise, if it had been just ESQL, everybody would have thought it would stand for Elasticsearch SQL and expected that it's SQL, but it's not SQL. It's a pipe query language. That's why there is this pipe. So it's very clear that it's not SQL or pretending to be Elasticsearch SQL. I was at least partially responsible for that name change because I said everybody will forever be confused if we call it ESQL. So we need to find something else, and then we settled on that pipe. So I'm Philipp. I've been working for Elastic for 7.5 or a bit more years, always doing events and showing what we can do, and then ideally solving problems. So if you have any questions today, just stop me at any moment, and we'll dive into whatever you want to know. So if you've ever worked with Elasticsearch, you know this one, the query DSL, where you have the underscore search endpoint, and then we have query, and then maybe we make a match, and I know Kung Fu. Everybody has seen that? How much does everybody like that way of writing queries? You're getting used to it. Okay, that's...
I can say it.
Yeah, that's probably a nice way of putting it. It also does the aggregations. So if you want to have, like, I don't know, we have characters and we want to have like which characters are the most common ones, we could do a term aggregation, and then you write it like this. And while JSON makes sense for anything that has JSON, it's probably not great for humans. And I always say it's a bit like the Stockholm syndrome, that you get so used to doing something that at some point you accept that this is the right way of doing it. And that has been us for some time. But maybe we can do something else and make that a bit easier for you. So I made that the matrix comparison when if you remember the movie, it's like, I think it was the blue pill, and you wake up again in your bed and you think it was a dream and everything is like it was before. Or you take that red pill, and then your entire world changes. And that's this new ESQL that has a new query endpoint, which is called underscore query, and how we can name that. So who knows how many query languages do use the underscore search endpoint, either directly or being transpiled to that or translated to that? Who thinks 1? Who thinks 3? 5? More than 5? Yeah, I think it's more than 5. We can, depending on how we count, we can come to different numbers. But the main one that we all know and use is the query DSL. But then there is also KQL. What did KQL stand for? The Kibana query language, yeah. How do you feel about that one? Yeah, it's very simple. Okay, it's better than Lucene. Yes, it has a couple of features like auto-completion and stuff like that. That's why we introduced it. But it's relatively limited in comparison. Then we have Lucene. There's also an underscore SQL endpoint, which translates to the query DSL. If you have used Kibana a lot, there's also Vega, which is like this scripted way of creating visualizations. It's kind of like an escape hatch for visualizations. Anybody knows EQL? I think it stands for Event Query Language, which ties into more the security side. It came from one of the companies that we bought. They had their own query language, which was EQL, that is being translated to query DSL as well. Maybe you still remember Timelion, which was ages ago, which was this .es, and then you had an opening bracket, and then you targeted the index, and then you could write your query like that. Maybe you still use query string for some simple queries, but anyway, there are lots of different query languages or queries that are using the underscore search endpoint that you can use. But we want to do something else today. So we take the red pill, and we see what's under there. And it took around 17 months or so of development. So just to show you what that looks like, that will be a joy to always hide that. This was the initial commit. Costin wrote the ESQL back then it didn't have the pipe yet, set up. And that was the very first commit that was pretty short. It was just like setting up the kind of like the profile. But that was the starting point. By now, we have a couple of people working full time on that. But this was the starting point of how we got into that. And ESQL has basically 3 different things to it. It is its own language. It has a query engine under the hood to make your queries faster. And it ties very much into visualizations or how you work in Kibana with everything. And it's more or less one query language end to end. So you don't have KQL for Kibana and Query DSL for Elasticsearch, but ESQL is for all the components, as I'll show you in a bit. Let's start with the language at first, because new languages are always interesting. It can work with structured and unstructured data. So structured would be we have all the fields nicely broken up. Unstructured could be we have like a log message that has some structure and we want to break it up at query or runtime. It is a procedural language that pipes one step into the next. So if you're using Bash or any other shell, that's very much the same concept, that you do something and you pipe it into the next command and then the next command. That's exactly how this query language works as well. It's kind of SQL-like, so you will recognize some keywords, and it can do lookups, or it's not full-blown joins, but it can fetch data from another index and enrich your data. And we'll look at some examples of all of those. Pipe query languages are not a a totally new invention from us. So Unix shells are like the original thing where this came from, but there are other query languages that look kind of similar or follow similar patterns. So for example, Splunk has SPL, the search processing language. Microsoft has Custo. Amazon's CloudWatch has another language. They all use a similar piped approach where you have basically one pipe where you pipe one step into the next. And because it's boring talking about the query language, let's look at the actual query language. So is it large enough for everybody to see? And I'll share the slides afterwards so you can have all the samples that I'm using here. The first command, so what I'm doing here is we have a post on underscore query. So rather than using underscore search, we're always going against underscore query. And then we have a query, and then I triple quote it, so I can then just write my query within that. And show info just shows me these are the available columns and these are the available values. So we have the version, which is a keyword, is 8.11 here in my example. We have a date, which is a keyword, and a hash. This is also a keyword. And these are the values that come back. This is a JSON structure. You could define the output format explicitly, that you say, I want JSON, even though this is the default. So this gives you the same thing. You could also say, I want to have this as a comma separated value. Then it would show you comma separated value, so version, date, hash, and then you have your 3 columns comma separated here. You can also do the same thing for text. Let me zoom a little bit around, and you can see here we have version, date, and hash. I will mostly stick to text for the demos because it's much easier to read than the other formats. You can also, by the way, here I have so far uppercased all the keywords. Those can be in any case. So show info with lowercase will do exactly the same thing. There is no difference to that. There are 1 or 2 places where upper and lowercase will still make a difference, but for the keywords in general, it doesn't. One thing that is already annoying me is that by default, it always throws this warning here, no limit defined, adding default limit of 500. So by default, it will return up to 500 rows, basically, of results. And now we are starting with the piping. So here I say pipe limit 1. I tell it, just give me one row. And this is what I'm getting back. So here I have version, date, hash, no stupid warning anymore. You can also do something like, what would be the SQL equivalent of this one? Keep version. Yes, exactly. For whatever reason, we stuck with keep here, but it seems to be a common thing in those piped query languages. So here we're using show info, we are piping it into limit 1. And then I'm saying, I only want to keep this one column the version that I want to keep. Everything else is being thrown away. You can do comments. You could either have single line comments or multi-line comments, and this will just do exactly the same, but you can, especially if you grow larger queries, like we have some queries that are like 30, 50 lines of operations, you might want to add comments to actually make that more workable. So you can throw it in here and just work with that. Now, one interesting question is, where do you put this pipe? And there are three different options. You just write everything in one line. And in this example, this is probably fine. In more complicated examples, you probably want to break it into multiple lines for better readability. You could have the pipe at the end, or you could have the pipe here at the beginning. What is better or worse, or just personal preference? Any ideas? Yeah?
I would put it at the beginning, so copy paste, the last line it shouldn't pipe to anything, right?
Yes.
If you have it at the start and then you copy paste the last line with the pipe, that would be.
That's an excellent point, because if I take this one out here and I run this query, it will say, well, there's a pipe, but there's nothing here. Whereas, that's not what I wanted. Whereas if I take out this line here, it will still run fine. So that's, even though it might look slightly weird at first, it's exactly right. Keep the pipe at the beginning of the line, because then you can just add a new line, remove a line, and play around with it. This is, by the way, one of the very nice features of this query language, is that you can go much more iteratively. Because if you have been using large queries, or especially aggregations in the query DSL, you were initially writing it, and then you were often debugging for 30 minutes. And it was very hard to break it down into smaller chunks. And the idea here is that it's a much more iterative approach, that you get the original info. Then we say, I want to get rid of that warning about the limit 500. So I limit to 1. Then I say, keep just this field. So you can really go line by line and edit, or take a part out and see what happens. It's a lot easier to debug and go step by step. Now, so far I've only been using show info, which is a bit boring. Let's use some actual data. I have an index with sample data, and I just want to show 5 columns of that. And we have a timestamp, a client IP, an event duration, and a message. And I'm not even sure if I have more examples in here, but it's a pretty small data set. Yeah, you can see we only have a couple of lines in here. So there is not so much going on. This is where we came from. I'm just looking what the difference is between those lines. I think those are just the same. Yes, you're very right. Will this work or will this not work?
Of course not, because you can't use a button. Yeah.
Yes. As we know from search, the problem with that is there is no right way here, or there is no winning, because get has no body defined, and especially if you have some proxies, they will throw them away.
I think the spec says that server should not consider it.
Yeah,
and again, that's what the MC says, but it's should is broad.
Should is broad. The other thing is, if you use a post, reading data with a post is also kind of wrong and not what you want. There is an HTTP verb search, but I think nobody has implemented that yet because it's so new. And I don't know how many years we'll have to wait, because everything around HTTP specs takes forever. Yeah. If you use post, you will be positively surprised, because so who thinks this will work? Who thinks this will fail? Well, let's try it out. So underscore query will only do post. It's a bit stricter in that regard. If this is more or less correct now, we can argue, but there's only one way of doing things, and one way is sometimes a bit simpler than giving you too many choices. So this one only does post. You have to add it explicitly, but you can add the metadata, like the index name, the ID, and the version from the document. And then it's too large to read, but you can kind of like get the idea here, that we have the ID of the document, the version, and the index name is sample data. So you can, if you need those for anything, you can get to them, but you need to explicitly add that in the from line, otherwise it will not be shown. It's because it's kind of like, yeah, metadata that most of the time you don't need, and we'll just strip it out to make your life a bit easier. We can do the keep that you have seen before here. I'm just keeping at timestamp and message. Everything else will be thrown out. This should not be surprising at this point. Now we can do a condition like where client IP equals this. Any guesses if this will work, or if this will fail, why it will fail? Yeah? Well, let's try it out. So first, this complains because, yeah, this is an assignment and it doesn't work. Now, if I do 2, will this work?
Yeah.
Yeah, no, it's fighting back, because it's saying that client IP with this string is an IP address, and then we have like an IP address trying to match on a keyword field. So it's kind of strongly typed in that regard, that it knows different types and it will fight back early on. So what you need to do, and that's why I've been moving this down so much that it's not visible immediately, you can convert, so you could convert either side. You could either convert the IP address to a string or the string to an IP address. I've gone for 2 IP here. It's one of the, there are quite a few functions that you can call here. I'm converting my string to an IP address. And then it will actually only match on this one line. But yeah, 2 equal signs is correct for the equality and not for an assignment. But then the data types still need to match, otherwise you'll get an error. This can sometimes be a bit tricky, and then you need to look up the functions or know your mapping of how to combine that. If you want to do something like is null or is not null, this will feel very familiar to SQL, where you have everything that is not null. This is basically all the data that I have. You can define it like this. And you can do aggregations. And the aggregations are quite a bit simpler or less to type. So what I'm doing here is, so the aggregation keyword is stats. And then I say count distinct client IPs and calculate the average of event duration and limit it to 1 line. Will that make sense for 1 line, or should I have more lines?
2 independent aggregations.
I mean, it's 2 independent aggregations, yes, but it will just do that over the entire data set. So if I run this, we have 4 unique IP addresses, and the average duration over all the rows is this. If you want to group that, the keyword you're looking for is by. Let's make it slightly more readable here. This is the example where you have from, and then we have stats where I want to have the average event duration and the count of rows grouped by client IP. So this is basically a group by, but the keywords are stats, whatever you want to calculate, by client IP. And then I can still limit it to 10, but I only have these 4 different ones, with this one having 4 different hits. So it's 7 documents in total, and this is how they are broken up. Yeah?
The fact that you are mentioning group by, you've chosen another terminology. What's the motivation behind that?
I don't really know. I have just seen that others are also, in the pipe query languages, are also using stats. I'm not sure if we have done usability tests or taken what others are doing. I don't really know. I was also slightly surprised when I saw it the first time, but I don't have a great answer. It's the keyword we have chosen for that one. I know that Amazon uses the same for the pipe query language. The other, like Custo and SPL, I don't know that well, but with Amazon, they use the same structure. I don't really know where it's coming from. I haven't. Maybe for next time I will do the research into where stats is coming from.
I come from SQL as well, so I think like you think. So
Yeah,
you're helping me, but it's just where does it come from? Since
yeah, that one I don't know. The thing is, it's kind of close to SQL in some regards, like the is null or is not null, for example, and a couple of others, but some are different, which is slightly tricky. When we get into the more visual way, by the way, there are helper tools to make your life a lot easier. We'll get to those in a moment as well. Next up, I have sorting. So here I have stats, average duration, and count by client IP. And I want to sort that by count. And that fails for some reason. Any guesses why this fails? Yeah? Yeah, here you don't need to alias it. Here you can just escape it because count star is like an expression or a function call, but we want to use the column here. That's why, at least it's one of the ways, but yeah, you could also have said as something and then use that as name, or you could escape it like this. So both of those would be possible. So here it will sort that correctly. Any guesses what happens if I lowercase this count? This will work, this will not work. Yeah, this will fail. So here upper and lowercase makes a difference. Not with the keywords, but by the column names are then case sensitive here. So that one will fail.
confirm that if we were to write lowercase count on the upper string, then it would.
I think that should work. I haven't tried it out. No. But it's a good validation. Whatever the right syntax for we can look it up in the docs afterwards. That one I have not tried out yet. And you can add, this is again more like SQL then, ascending and descending. So far, we had the ones first. If we want to have the higher count first, so descending, you would need to add the modifier descending, since it's ascending by default. One thing that is, I think, an important concept in this query language and to explain is that it is procedural. It's not like SQL where the query planner will rewrite your query freely, but it's really procedural that one step pipes into the next and into the next. So you define like in the order in which stuff happens. That also means you can call something like limit multiple times and change your results. So it's like you have new powers, but you also need to know how to use those powers correctly. So for example, here I'm doing from my sample data, and then I have the stats, average event duration count like before, and I limit it to 5. And here, these are only 5 results. Now, what happens if I pull those limit 5 up and put it before? Yeah.
Only be working on the first 4.
Yes, I will only work on the first 5. So if I run this now this one is losing or missing the last 2. So this has now changed the result set. Or you could do that in multiple steps. So we could do a limit to 5, aggregation, sorting, and then we limit to 1. And then we get this 2 from before is the top one. So you can call the limit multiple times and influence it like that. By the way, one thing, because limit is, if I don't specify limit, the final limit is 500 here. You could increase it to 10,000. This is like with query DSL that you can get at most 10,000 documents back. This does not mean that the aggregation only takes 500 or 10,000. The aggregation still runs on the entire document set. Only the returned rows are limited to 10,000 or 500 by default, because that was sometimes a confusion. Okay. Just to show you a couple of other features. Now I'm simulating. So there is another concept. So we have we've seen info, we have seen the select, sorry, the from, and the row. With row, I basically say work on this input. So you can just at query time say I want to use dissect with this pattern. Who remembers what dissect was? Dissect is like the little brother of grok. So grok are the named regular expressions. Dissect is not a full regular expression. It's more like these patterns. So it's less powerful, but it's also easier to use, and it's also much faster. So sometimes when it's a simple pattern, and you don't need to validate anything in here or break up more complicated patterns, you can just use dissect, and it's easier because here I say dissect this row A that I have specified, and it exists like we have a date, then we have space dash space, then we have the message, and then we have the IP. And then I just want to keep date message IP and limit 1, and you get those nicely broken out. So this is kind of like you have an unstructured message and you want to structure it at query time. Why did I need this line? What would happen if I take out this line? No, it will. I mean, it's after the dissect. So sorry? Yes, you get the A as well, which you might not want. I mean, it's hard to see here, but here you include the original message, and with the where it went. With this one, with keep, only those 3 fields, I get rid of the original message because I don't need that anymore. And then we have full-blown grok as well. For example, here I have an email address, and then I will validate the email address and put it into the email field. So if I wouldn't have a valid email address, this should not work. Here I also added a comment. And you could switch, yeah, we can do that. We can switch those 2 around. So first, let's run it like it is. So here I have broken out IP, email, num, and date. Why is date the last one, even though it's the first one in the keep? And I mean, you should generally not rely on the ordering too much because it might change. But the thing is, I'm using an eval, so an evaluation here. I'm parsing the date to a date time type because I manipulated the date last. That's why it ends here last. If I would switch this one up on top of the keep, then I would keep that order from the keep. Otherwise, it changes the order.
So the first the grok thing, that's timestamp ISO thing. What does 2 datetime do that kind of cast doesn't do? The one in 251.
Oh yeah, that's kind of unnecessary at this point. It was more just to show the function call, yeah. But if we have, yeah, true. It's only so sorry. This is using the pattern, and this is the field where you put it in. This is a different than 2 datetime.
So the first one is just the pattern saying it's an ISO, and the second one.
So this is the sorry. This is the grok pattern that knows how to operate on this. This is the target field where to put it in. The other thing that grok can also do the yes, you can also that. Yeah, that's what I looked at first. But because you could have the data type like this, then it would put it into that right away. What is, by the way, interesting is that here the date we override directly with 2 datetime. So you can also do that. And this will not error out. No, but we have now a date rather than a keyword that we could manipulate.
Change the type. The data there.
Yeah.
You can see it.
Let me see. I'm sure we have some we have some date functions here that we can call on this one. String datetime. Let's take this one. Date extract, let's say year, and that should work on, bless you. Let's hope I'm not lying to you. We could wrap this. Let's see. And then you, because now we don't operate on like a string. I mean, there are also substring operations. So if you know the pattern, you could just say like, give me the first 4 characters. But now we have proper date manipulations. I'll add that for next time because I think that's a good addition, because otherwise, yeah, like you said, it doesn't do much. Showing you eval, previously we would have pushed this more to the application and said like, this should be handled in your application. But what I have here is I have Philipp, so I have myself and I have my height 181. And then I say, I want to have the height in feet. And I think it's approximately times 3,281. And I want to also convert my height to centimeters. And then I will basically add those new fields, and they will just be calculated on the spot here. And you can also operate on whatever you have calculated here. So for example, now I'm doing a BMI, the body mass index calculation. So I have my height and weight. I do weight divided by the square, whatever, or power of 2. Square, what is it called? Square.
Square.
That's, oh yeah, okay. My square height. And then I round this to just 1 point after the comma, because otherwise it would be very unreadable. And then I have a case where I basically say, if my BMI is, so this is the BMI that I've calculated here. If my BMI is under 18.5, I say healthy is false. If it's over 25, it's also false, and otherwise it falls back to true. And so this will give you the height, the weight, the BMI that we've calculated, and then the healthy based on this condition. So you can add new fields or flags based on a case decision. One thing that is a bit tricky are multi-valued fields. I was always confused by multi-valued when somebody said that, but it's basically when you have an array. And you can do, on single values, you can do operations, you can output these arrays, but most calculations or functions are not defined on those. So they will just give you nullback. So I say a minus 3, so 5 minus 3 is 2. It's this one. But the array, it doesn't really know how to operate on these here, and then it just gives you nullback, unless it's otherwise specified differently in the documentation. Final thing before we stop with all the queries, because it's a lot. There are a lot more features and functions and everything. This is more for the concepts. Who remembers what an enrich was? Yeah.
Doing a lookup in different mixes.
Yes. So sometimes, or generally, we advertise denormalization because it's much faster. So you only need to fetch a single document and then you're done. SQL has joins. This is not proper or full joins, but enrichment is that we can have, we have additional source data, and we create this enrich index, and then basically we match from the input, we match on this red column, the A, B, C, D, we match it with this enrich index, and then basically we get this out plus the enrichment that we get from here. So this is at runtime, we add some information. So for example, if you have some extra information about an IP address, and every time you store the IP address, you don't want to add that information, but you want to do that at runtime, you could do that. That's, I think, pretty much what we are doing here. So we have specified the enrich policy. So we have an enrich policy that works on client IPs, just to show you what is in client IPs. So we have these IP addresses, and this is development, QA, production, and you could reassign those. Now what we're doing is we keep our same sample data. We take the client IP, we keep all of those fields, and then we evaluate the client IP. We put that to a toString because right now match only works on keywords, not on IP fields, for example. This is where we need the other way around. Before we did 2 IP, now we need 2 string. And then I run my enrich policy on the client IP policy. So that was the policy that I've shown you here before that we've prepared on the client IP and with the environment. So the environment is what we want to enrich or add, basically. So if I run that, now we have here the 3 fields from before, plus the environment added to all of those documents. And we have done that enrichment. What is nice is that doing the same as before, you could then do further steps on those enrichments. So here I'm using an aggregation again. So I'm calculating the median duration by the environment. So we have added the environment, and then we're aggregating not on the IP directly, but through the environment, and can calculate that. So it's piping to the next step. You were first, I think.
Regarding the 10,000 units,
Yes.
how is that operating within this? Can you enrich further than 10,000, or will you reach the 10,000 with enrichment, and then that's where you?
No, if I remember correctly, the enrichment, the enrichment only does a lookup based on each keyword in the enrich index. So it's like a match.
Yeah. Can we enrich 100,000 and then do something about that? Or
You can, but it will be slow.
so the language will not restrict that.
No, I don't think that it should do that. I think that's like the enrich policy has always been working. And it's basically, I think right now it's more like a terms lookup. You could do that in the past as well. And it will just look those up. But I have talked to customers who had they said after a certain threshold, this will get slow. The other thing is that you don't just, the source index is not just updated, but you need to prepare it that it's stored in an optimized way that you can do a lookup. So it's not for a data structure, the lookup does not work very well against a data structure that changes very frequently. If it's more like a static data set against which you enrich, that works pretty well, and it can be larger. But there are some limits against or around those lookups. You had another question.
So what kind of performance difference are we talking about, enrich versus just denormalization?
Denormalization will, of course, be much faster because you just look up one thing. On the other hand, if you enrich with a lot of information and you have a ton of documents, it might just be a huge amount of data. The other thing is this runtime enrichment works very well for things that can change or where you might want to update these here. Because otherwise you could run an update by query, but with the immutability of Lucene, you basically re-index every single document that you touch, and that would be very expensive. So in that regard, it might be helpful. On the other hand, there's also the correctness aspect. So for example, IP addresses can get reassigned, but they don't really change when something happened. The reassignment doesn't change that. So there, the correct way would be the index time enrichment. So there is, I think, both a correctness part to it, but there is also a performance part then to it that you need to consider. And it will only be applicable if it's the correct either way. And then you will need to figure out how much enrichment would you save, and is the extra query time worth the safe disk space and also indexing overhead, because the smaller the document, the easier it is to index. So if you add 30 or 50 or whatever extra fields, maybe you're happy to pay the query time penalty rather than the index time penalty, but depends very much on your access patterns.
Follow-up question?
Sure.
Is there a way to know something about the performance of each of these procedures in each of the lines?
That is not implemented yet, but that's coming. I have a slide for the way to general availability, because this is tech preview. It came out in 8.11. It's not stable yet. I won't say any dates or even releases when it will be stable, but we're working pretty actively on a couple of things there. So that was kind of like the query language in the quick run through. So far, so good. Okay, I won't put this in full screen because otherwise I have to fight the Zoom thingy again. Just make this larger. So that was the query language. That's the obvious thing. Under the hood, ESQL was also rebuilt from the ground up for more performance because it operates now on blocks rather than on rows. It uses vectorization, the Java feature, not as in vectors or vector search, but vectorization as the Java feature, which makes operations faster and more cache locality. And it is also multi-threaded, either per document or per segment. So you will get more performance out of that. There is the ESQL nightly benchmarking track, which you can see. Let me just open that one here. So you can see this is the classic aggregation. This, in a recent change, is also multi-threaded based on the segment. So if previously it was per shard, this was per shard, then we added a change that added that's multi-threading per segment. If you have multiple segments, it got faster. And ESQL per shard is then slower, but we stopped doing that because now there we have either document partitioning or segment partitioning. And you can see those two with ESQL are still much faster than the classic search aggregation, even per segment parallelization. And like there are a ton of different queries here. ESQL is most of the time faster, not always. There are more optimizations coming, but for many queries, ESQL queries, or especially the aggregations, will be faster than search aggregations or the classic query DSL aggregations. So you will, depending on the query, it might be twice as fast or maybe 5 times as fast, but there is, in many use cases, your aggregations will be quite a bit faster than before, which should be one of the reasons to upgrade. And then there is the visualization part, or how to integrate all of this. So when you go to Kibana, this is what you all know, right? The first problem is, where is ESQL hiding? Because at first I was expecting, because I think that's how we switched Lucene and KQL, you had a switcher here, but there's no switcher here. What you need to do is you open the drop down of the data views, and then you have try ESQL, and this switches, this is the red pill. This is how you switch the world. And now you can see here I have from Apache logs limit 10. So you can write your query here. You can make this larger. The other thing that is very handy here is that it has the documentation built in. So it has all the keywords. And for example, if I don't remember how StatSpy was working, I can just search for it. And then it gives me examples and how it works. And then you don't need to jump to another documentation page. So this will also make the learning curve much simpler. Did we reach the time limit?
Yeah.
Is this the alarm that we're supposed to be gone?
No.
So previously, you often had to go to the documentation and then you had to jump around. What we are really trying to do here is to keep you on this page. That first, the documentation is here. Also, when you're building visualizations, what you previously were doing, you were often looking into your data here in Discover, and then you would go to Lens, and then you would kind of like try to drag and drop the same thing around. The nice thing here is, and let me just open one of the saved queries so that I don't have to search too much around. So here I have the bad syntax because I have the pipe at the end, but it doesn't matter. So here I say, from the Apache logs, where the URL equals login, and then I do this auto bucketing. So I group it into these 3 buckets, and then I group by the username per time bucket and username, and then I sort it by the login attempts. And this is the visualization I get out of this. What is really nice is that here I can just edit that visualization, and then I could change it right away. So you don't have to jump over to Lens, but you can change it right here. And you can see all the fields that are available. You can adjust your query, and you can just work on your visualization. Like these will all look very familiar to users of Lens. You can also say in this drop down here, I want to change the chart. So this is what I want to have this
So we actually got to evaluate this from the Linux lab with a colleague.
Uh-huh.
It was a trial. The first thing I noticed was that the visualization is not saved in the query string array. So if I reload, whatever, it defaults always to the columns. This is not a question. It's just
That might be more of a bug. So there are quite a few things also in Kibana that are on the way to a stable release.
yeah, it's pretty.
Yeah. I mean, don't be sorry. It's like, we want to fix this, or like we want to make this better, but yeah, it's a bit limited and not everything is stable, yet. By the way, this is a,
But from the question here, if you change it to pi or whatever, can you still copy that out, the fact that you're changing the selection? Is that going to the query as well, or something else, or you could modify the visualization at the right?
you mean, I don't know, I removed this.
So this is basically the query, right? And the visualization is visualizing the output of the application.
Yeah.
But you on the right, you could modify the visualization, so like let's
Yeah.
But if you'd go and drag and drop a new vertical axis or break it down.
Yeah, that is probably not a very good. I mean, we could, for example, we can have the login attempts here as a second. No. Okay, we pick this one here, and then it goes back to that.
So you can select from what is output from the query.
Yeah.
But it hasn't changed the query itself.
It's the query, the query.
No.
The query is what you can visualize based on.
No,
It's not
yeah, either you write the query or you click around. The date picker should mostly now work for this. So if you change the date picker, it will also influence the data that we're selecting here and that we are visualizing here. But again, I think there are a couple of small bugs in here that we will need to fix over time, but we're making some improvements. Now, this is like ESQL demo.elastic.co. You can access that today with all the same data, so you can try all of the same queries. The downside is normally there would be a save button here with a blue background. I don't have that save button but for that reason, but you could create whatever visualization you have. You could save it and throw it right into a dashboard. So you have fewer places where you need to try to put things together to get to a working dashboard and explore your data. The other thing that is very cool here, based on the query that I have here, I could say, I want to create an alert. And it will keep the same query that I've had here. So you don't need to create some query or try to recreate it in an alerting view, but you can just reuse whatever query you have written here to slice and dice your data. You can take that right into an alerting role. You give it a name, and then you say on what you want to select, and then you can say like, I want to, I don't know, run this every 5 minutes, and you could also define a condition of when to actually trigger an alert. But the idea here is that it's all more in Discover, because at the end of the day, you were spending a ton of time in Discover anyway. So we are trying to bring more of these features to Discover, that you can do everything here and that you don't need to have like 5 windows open or jump between 5 tabs, because I think that's what we all did before quite a bit. Yeah.
So what happened to data groups? I think we have from Apache logs and this. We still like.
That's basically the data group from.
Yeah, the from is, and you can hear.
So that's a data view. It's not.
No, this is the index pattern, and you can also use the, you have this when you define multiple indices. You could also define a wildcard. You have the time calculations where you say today date or whatever, or today with the day and precision to resolve indices. All of those you have available here.
So we don't. So data views are not really good for this anymore.
The data views is basically just the
Okay.
alias you can put, the pretty names. Instead of you always had to have the index pattern as the name in Kibana, and you could have these horrible long index comma star something.
Yeah.
Now you can give them a pretty name. Say,
You-
this is my logs.
Yeah, you could basically create these groupings for Kibana, and then Kibana would also know the columns and everything. But ESQL is working outside of that realm, basically. Cool. We have seen all of these. So to wrap up, there's a lot of stuff that has gone into this. There is also a lot of stuff missing. The one thing I think that is most obvious that is missing is, like, we always talk about search. While you can do keyword searches, you can also do regular expressions. It's not full text search. It does not work on text fields, basically. Everything is keyword based. Some data types are not supported. So if you have flattened or nested or a couple of others that are not supported yet, there is no async search. That will be added very soon because Kibana is a very heavy user of async search. There's no pagination right now. For those using large security setups, there is no cross-cluster search. So you can only search in a local cluster. That is also very high on the priority list, or a bit more complicated. Time series data streams are also not supported right now. And the other thing that everybody asks is, like, what about language clients? They are work in progress. I think what I'm allowed to say is, when this reaches GA, the clients will also be available. And it's not super far off, and it's under active development, but there are no language clients right now. And some open questions around them.
Full text search, is it something that is deliberately not there, or it's just something that's coming?
That it's coming.
It's coming.
Yeah. So the idea is that this will cover hopefully everything and more than what the Query DSL is doing today. So this is just, we haven't really specified of how that will look like and how to implement all of those features. Just because I think the places where you want this the most right now is observability and security. Also because KQL, like I said, was a bit of a pain to use, and you can just pipe together what you want, and you can do the alerts. Full text search, probably everybody has a million lines of Query DSL out there to do full text search. So I think that's a bit of a longer tail for replacement as well. So we'll add that afterwards, and we'll see how that goes, if it will be significantly simpler. I hope it will be compelling for people to switch, also if it will be faster. But I think the immediate target is more of for security and observability use cases where you pipe down to, like, give me these logs and group together or whatever. Because there in Kibana, what you were often doing, if you had, like, the Apache logs, you were then starting to type here, and then you maybe were saying, like, oh, I need a structured filter, and then you were starting to click around here, and it's kind of like this messy combination of things that you needed to get it to work to what you want. And ESQL tries to unify all of this. Cool. The things that are coming before GA is mostly stability, less new features and concepts. So full text search will not be part of the GA release. That will come after GA. It's really about making this stable and performant, improving some things in Kibana because there are also some rough edges, and improving the documentation. That is the main focus of what we want to get here. One thing that Elastic is generally pretty focused on is this unified versus specialized. So in Elasticsearch, or in Elastic, there's one engine to store all the data and one query language to query everything, ESQL. There's a very deliberate choice, whereas other systems have, like, for one specific use case, they have a different query language, which might be faster to develop, but we think that it's much easier if everybody has the same query language to work against. That's why we are going down that route. If you want to try this out, ESQL demo.elastic.co is where the data is, and you can just go there and play around with that. There is the reference documentation for ESQL. This has way more features than I've shown you, but A, we're adding more, and B, nobody will remember all of those. So I'm not trying to show you all the functions and features that we have in there. So to wrap up, there's the language, there's the engine under the hood, and there is the visualization. And those three together make up ESQL. So it's not just the query language itself, but it's really more about the overall approach that we are trying to do.